Today we're going to talk about the interim review, the interim test that'll be this Friday. So just going to review some of the concepts of Chapter 2. And it starts off with, number 1, with additive inverses, or adding opposites. And when we add opposites, we learned in the integer card game that sum is 0. Number 2 also is additive inverses. When you add or sum additive inverses, or when you add opposites, you get a sum of 0. Number 3 is showing us to write this model, a bar model that you see here, as a fraction, a percent, and a decimal. Well, the first thing I have to decide is what part of my picture is shaded. And I can see that the bar, or the rectangle, is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes, and 1, 2, 3, 4, 5, 6. 6/10 of them are shaded. Write this model as a fraction, 6/10. As a percent, I would do it as a decimal next. Percent, 6/10 is equal to what out of 100? Make an equivalent fraction there. So 6 times 10, because 10 times 10 would give me 100. 6 times 10 would give me 60. 60 hundredths is the same thing as 60%. So there it is as a percent. And to write it as a decimal, well, 6/10, 6 divided by 10, is also the decimal if I was doing the long division, or you know it as the place value, tenths. 6/10 is the decimal, 0 and 6/10. You don't really have to have the 0 there. So as a fraction, it's 6/10. As a percent, it's 60%. And as a decimal, it's 6/10. That's our little FDP review, fraction, decimal, and percents. A number line that we see here, and usually the numbers are below the number line, but in this model, this is just the way it copied. The numbers are above the number line. I know that looks a little weird. So write the numerical expression illustrated above. Well, we use number lines to show adding and subtracting. You always start at 0, and the first arrow is pointing to -2. So this must be -2. And since it's now the second upper arrow is pointing to the right, it must be adding 1, 2, 3, 4, 5. It must be adding 5 to get the answer of value of 3. So that numerical expression that matches that number line is -2. Start at 0, go to the first number, so that must be -2, plus 5, because the arrow is pointing to the right, and I did count how many hops is it going to the right. 1, 2, 3, 4, 5. -2 plus 5 is the expression. And again, expression, because expressions do not have equal signs. So I did not put an equal sign on that. I didn't say equals 3. It does equal 3, but we don't have to put an equal sign on an expression. Number 5, what is the additive inverse of the following? Well, you say opposite, I say additive inverse. That is the true mathematical terminology there. So what is the additive inverse of 3? -3. What is the additive inverse of -7? +7. What is the additive inverse of -14? +14. Do you have to write the positive sign? No. When we sum these, as we saw in number 1, 3 and -3, their sum would be 0. When we sum -7 and 7, that sum would be 0. When we sum -14 and +14, that sum would be 0. Another thing to remember about additive inverses, they are on the opposite side of 0 on the number line. So they're on the opposite side of 0 on the number line. Opposite side of 0 on the number line. They have the same absolute value as well. Additive inverses have the same absolute value because they're the same distance from 0 on the number line. Number 6, Mindy had 1 1/3 cups of flour, 3 1/2 cups of sugar, and 2 7/12 cups of brown sugar. How many cups did she have in all? So what's the total amount of her ingredients here? She must be baking, it looks like. So I got to get a common denominator. I'm not going to make them improper. Don't want to make them improper. I'm going to just keep my whole number and fraction parts separate. 3, 2, and 12 has a common denominator of 12ths. So I get 4 12ths, 1 and 4 12ths. 2 times 6, so 6 12ths, 3 and 6 12ths. And my 2 and 7 12ths is already in 12ths. So when I add those together, I get 4 and 6 is 10 and 7 makes 17 12ths, improper fraction. 1 and 3 is 4 and 2 is 6. So I'm going to change that because this 12 17ths equals 1 and 5, this 17 12, sorry. 17 12ths equals 1 and 5 12ths. Adding to that 6, you get 7 and 5 12ths. So my answer is 7 and 5 12ths. Next page. Number 7 says, write 7 55 hundredths as a mixed number in lowest terms. And if you read it mathematically correct, 7 and 55 hundredths. That should give you a hint about it being 55 over its place value, hundredths, 7 and 55 hundredths. In lowest terms, well, 55 hundredths, not lowest terms, so we can divide both the numerator and the denominator by 5 to simplify that. One ends in 0, one ends in 5. And you get 7 and 11 twentieths. 7 and 11 twentieths. So changing a decimal to a mixed number in lowest terms. I don't know how to do that. Number 8, subtracting some rational numbers. 7/8 minus 1/3. 7/8 minus 1/3. Got to get a common denominator here. Common denominator of 24. So 7/8 as 24ths is 21 24ths. 1/3 as 24ths is 8 24ths. So I get 13 24ths when I subtract 21. Take away 8 is 13 24ths. Final answer there. That is in lowest terms as also. And we do want to make sure that we put our fractions in lowest terms on this interim assessment. Convert 2 15ths to a decimal. Part B says round your answer to the nearest hundredth. 2 divided by, the fraction bar there means division. So I've got to do the long division of 2 divided by 15. Well, the decimal on 2 is right after 2, so I'm going to put that up into my quotient. There isn't a decimal in my divisor, 15, so I don't have to move any decimal points. And I'm going to annex a 0 and keep going until I have no remainder, or round your answer to the nearest hundred, 2 15ths. So 15 does not go into 2. It does go into 20 once. When I subtract, I get 5. Annex another 0, bring it down. 15 goes into 50 3 times, right over the top here. 3 times 15 is 45. Sorry about that. Subtracting, I get a 5. Annexing a 0. 15 goes into 50 3 times 45. Oh, my work seems to be repeating here. So do I have enough to round to the nearest hundredth? I have a thousandths place. I have a thousandths place. This is where they want me to round to. Well, a 3 with a 3 sitting after it, this is normally a repeating decimal. How I would show that is putting the bar over the last 3 there. And yes, it does keep repeating, but rounding to the nearest hundredth, we're not going to put that bar notation on the answer because this 3 is going to remain a 3 because there's a 3 sitting in the thousandths place. So to the nearest hundredth, I guess I'll put my answer down here, would be 13 hundredths. No bar notation on that. And the last question for today for the review, On Tuesday, January 7th, Martha Brown had a cold day. Yes, we did. At 3 a.m., the temperature was -1 degrees. It dropped another 7 degrees by 6 a.m. Finally, by 11 a.m., the temperature rose 9 degrees. Write an expression to find the temperature at 11 a.m. after it finally rose there. So my starting temperature was -1. It dropped, so I'm going to drop, subtraction, another 7 degrees, so 7 degrees, by 6 a.m. Finally, by 11 a.m., the temperature rose, so I'm going to add 9 degrees onto that. Write an expression, again, the word expression, so we're not going to put an equal sign on there because it's just an expression. Evaluate the expression to find the temperature at 11 a.m. Okay, so now we're going to find out what is -1 minus 7 plus 9. Well, in my order of operations, adding and subtracting are equal operations. You solve them left to right. So I'm going to go ahead and solve left, that subtraction, first. So what I'm going to do first, to right. Subtraction comes on the left, and I'm going to solve left to right. So -1 minus 7, subtraction is changed to add the opposite, plus 9. So now I have -1 plus -7, same signs, add in, keep, 1 and 7 makes 8, keep -8 plus 9. Now I have different signs, subtract, so now I'm doing that adding, which they have different signs, so I'm going to subtract them. 9 take away 8 gives me 1. So now my temperature, which was at -8 by 6 a.m., then it rose 9 degrees to 11 a.m. If it was at -8 and it rises 9 degrees, that would give me 1 degree Fahrenheit as my final answer at 11 a.m. So tomorrow we're going to have the interim assessment and use all of our skills that we've been practicing in Chapter 2. And that's it for today.